Hey everyone, welcome back. We have another great session coming right at you here. One of my favorite types of sessions is a live coding session. I love when people write code live. It's a hard thing to do, but when done well, it's very impactful. We have Erdem talking about Spring, Kafka, and Elasticsearch. It's a great use case story highlighting how these three technologies have helped him improve his users' use cases and application use. So I'll turn it over to Erdem to get started.
Thank you very much. I hope I will be able to fit everything in 25 minutes, and I hope it will be useful for audience. As explained greatly, I am going to explain what I have learned, what I have gained in one of my recent projects using Elasticsearch, Kafka, and Spring framework to come up with a personalized search results. It is going to be a demo-driven presentation and then live coding as well. I'm gonna demonstrate what we have done actually, and I'm gonna continue with how we did it. This is a search problem we have to find first. So here comes Elasticsearch, and then I'm gonna show you how to boost the search results based on content's popularity or ranking. And finally, I'm gonna add user behavior ingredient to boost the results per user. Here is a quick example of what we have gained at the end of the project. On the left, there is a user, neutral user who do not have any behavior in the system. So they get the results based on community rankings. This user listening to Turkish music, so typing only one letter E, this user gets the results for Turkish content, Turkish music content, and this one listening to English or foreign musics gets a totally different results. I'm gonna display how we did it. I'm gonna first demonstrate, as I said, the application. This is our mobile application, Fizi, which is used for listening to music. In this page, you can see that I have today recently played these two great singers. They all start with letter C. So I'm going to go to search. I'm going to type only one letter C. And as you can see, I'm going to get these two great artists listed on top for me based on my today's behavior. Yeah, this is basically what we have gained. I'm gonna look for the second artist. If I type it correctly, I will always get it. Cem Karaca. I will always find this artist here as the first one. But what if I make some mistakes? Like I put some irrelevant characters in between. Should I still be able to get this artist? Yes. For example, I put additional stuff, spaces, I can still find. So first we will go into finding the content, and then we will go to the boosting, how we can boost the content based on popularity and user behavior. I always forget to mention a few words about myself. I started working with Layermark this year after working 16 years at Turkcell. At Layermark, we are specialized in GIS-based solutions, mainly field mobility solutions, land management and cadastre solutions, and stormwater management solutions. We are partnering with CMMI and Esri companies. I am the founder of Istanbul Spring Meetup, where we are almost 5,000 people in the Meetup group and regularly organizing meetups based on Spring framework. Everything I'm going to display today is listed in this repository, Günay's Elasticsearch. You can reach everything from here. What I'm going to do, I'm going to start with Elasticsearch part from scratch and explain how we could make this project by coding live here. If I look at my current indices in Elasticsearch, I can see that I have a content index, I have a user profile, I have listen events. I'm going to delete all of them. I'm going to start from scratch. So if I perform this query, I get an exception, index not found. What I will do, I will index 4 contents in content index with the basic Elasticsearch default behavior. And then I can see that the content are listed. I can find them. But what if I try to find the content with 1 letter? I cannot find. Okay, let me continue. I'm going to try to find this artist. I type 2 letters, no luck. Still, I cannot find. I have to type everything until I am able to find this artist. This is not good. I should be able to find with 1 letter, 2 letters, etc. Let me look at another scenario. Helen Segara, I'm typing the whole word, but still cannot find because I have to pay attention to the accented characters. I have to provide exactly the same thing. But this is not the real world. I have to solve this problem. How I'm going to solve this problem is utilizing Elasticsearch analyzers. Okay, let me take this example here, and then what I will do, I will see the default behavior. This is Elasticsearch's default behavior, but this is not good because it is leaving all the accented characters and special characters here. I should get rid of. So what I will do, I will extend this with some special character filters and token filters. I have to. First, I need to remove this character. So what I will do, I will put this character filter, which is basically replacing everything which is not alphanumeric character. Okay, let me try. I'm expecting this apostrophe getting removed. It is gone. So I'm not expecting the user to fill in all the special characters in the search, but still this is not enough because I still have non-ASCII characters. I have capital letters. I need to get rid of these ones as well. So what I'm going to do is I'm going to add token filters. This is an array of filters. I will do ASCII folding first. Let's see that accented characters are gone. And then I'm going to do lowercase, another token filter, which will remove the capital letters. Looks good, but this is still not enough for me to query, to search with 1 letter or 2 letters. I have to add one more thing, which is an engram filter. What it will do, it's an edge engram. It will separate, it will create tokens based on the engrams like this, H, HE, HEL. Now with this configuration, I can find, I'm going to show you, I can find the content I'm looking for with 1 letter. In order for this to run, I have to delete the content index and create the index with predefined configuration because I need all these analyzer settings in my index. Otherwise, I still will not be able to succeed. I'm going to delete the content index. I'm going to create the index with a special field, which has a special analyzer, index analyzer and query analyzer. If I re-index all my content again, and this time if I look for S, I still cannot find because my content, the generated tokens are not stored in artist name field. They are stored in artist name prefix field now. Okay, if I run the query, I can find all my 4 content because they all start somewhere with S. What I can do, I can play with it. If I want to still search for artist name, which makes sense because if there is a complete match, I should expect a bigger score. For example, this one, I should expect a bigger score than the other matching content. I can even do this if it matches from this field, 5 times boosting. If it matches from prefix, 1 time boosting. We do not understand the difference because there is no other content matching with Sezen. So what I'm gonna do in the multi-match query, I'm gonna add fuzziness 1. This will match other artists like still Sezen Aksu, but Selena is also here. But you can see the difference. It is almost 5 times more higher boosting. So going to the Spring one, going to Spring World, how I can make this available to my client applications is through Spring REST controller, Spring Boot project. This is typical Spring Boot project. In my project, I have Spring Boot Starter 2.5.4. I have got Elasticsearch REST high-level client and then Spring Kafka. These dependencies will be enough to make the whole system working properly. When I try to reach the results through my API, this is running on port 8080, what I'm gonna provide is one letter S. I'm gonna see the results, but the results are not boosted with any factor yet. Let's see how we do it. With the search controller, I get the input, and then I send the request to my service bean, Spring service bean. Let me make this complete the whole page. If you want to make queries to Elasticsearch, you need to provide search request, search source builder, and then provide, like I did in the Kibana screen, which fields you want to use for search and how you want to manage your search results. For example, if fuzziness 0, I'm going to give higher boosting factors, but if fuzziness 1, because I don't want to miss typos, but this time I'm going to provide lower, much lower boosting factor. So I'm going to get the results based on these fields. Once I do that, I need to send the request to Elasticsearch and then process the response hits. Since I don't have too much time, I cannot go into too much details, but you can always refer to the project from GitHub and analyze and ask me any questions anytime. I'm happy to answer. So let's move on to the second part, which is boosting the results based on popularity. Let's go back to Kibana. We can see clearly that these artists do not have the same popularity. Sezen Aksu is the most popular. Elen Segara is the least popular artist in the ecosystem. But I cannot, when I do a search here with S, as you saw before, Shakira is the first one. Sezen Aksu, Selena Gomez, Elen Segara. The popularity is not taken into consideration. If I want to use popularity affecting the search results, I need to provide functions, scoring functions. This is an example here, taking the popularity into account, ranking into the account, and changing the order of the search results. It is very simple. It is still a basic query, the same query, basically with one letter S, and then some list of functions. This function is pure mathematical function. What it does, if the document has the ranking field, it's going to take log 10 of the ranking value. You can apply any function you want, you need. Here, let's run this query, but this time we should see all the artists sorted based on their ranking. Here, this makes 3 times, a bit more than 3 times the least popular artist and sorted accordingly. You see ranking 1000, 100, 10, and 1. It is very simple to apply in your project. If the user wants to include ranking in the results, all we have to do is add this function, which is the same thing as you have seen in Kibana, in the function filter function builders list, and then it will be applied to the search results. Let's see. here, this is my the same API, the same REST service, still searching with the query string S, but this time include ranking true. That will include that function in the Elasticsearch request. If I run it, I get the same result. Sorted content, artists are sorted based on their ranking, their popularity. So if I dynamically increase the ranking of one of the artists, let's give it a try. For example, Elen Segara, she is the least popular. What I'm gonna do, I'm gonna make that she is listened to 200 times. Okay, let me see from my command line. I can see that the messages are processed. First, the messages are sent to Kafka topic, sending message to topic. Here I can clearly see that artist ID is A4, which is Elen Segara. And from the same process, I have consumer and producer in the same process to make the things easy. All 200 messages are received and they are put in a special index. Now I should show you these indices, okay? Because I have to process the messages, listen, these are the listen event messages that are received from Kafka and placed in the listen event indices per minute. And then I should see user profiles are also getting generated. User one profile is containing artist A4 200 times. And if I aggregate the results, listen events per artist ID, I can see that A4 is listened to 200 times. So the process, the application, what it will do, it will also update the ranking in the artist document. So it will both update the artist document and it will also generate the user profile, which is going to be used in the third step for user behavior-based boosting. So I can see that it is 201 now, Elen Segara. She was the last one, you remember, when we did the ranking-based search. Now at runtime, this is quite near real time. Near real time, as she was listened, I make the same search and I can see that she is returned to me in the second place now because of this ranking value updated to 200 plus 200 value. So imagine your system, like your users are listening to music or doing some activities. You are updating the content documents, whatever the content is. It can be song, it can be artist, it can be anything. You keep updating real time and the search results on the field get updated automatically near real time for your users. So this was the second one in my boosting, in my agenda. The third and the last one is boosting by user behavior. So I need to take another function into account in order to change the results per user. If a user has a profile in the system, if I can show you again the user profile, I have profile only for one user, which is user one and listening to A4, Elen Segara. I do not have another user, so this user should be seeing different results. In order to make sense, I'm gonna send another listen events for another user, which is user 2 and A3. Again, 200, doesn't matter. Once this is processed at the end of this minute, I should see user profile for user 2 as well. Currently, I still don't see it because raw listen events are not processed yet. Once they are processed, I will have profile for 2 different users. Until that is processed, I'm going to show you the function, okay, which is again in my repository. This time, I should put another function into account rather than ranking. I'm going to run another function in order to change the boost in order to change the score, document scores. This time, again, the same query, again, the same function list, but this time function is different. I can determine which artists have which ranking boosting factor, not ranking, sorry, boosting factor based on the user profile, because I know which artists are listened to by which users. Depending on the user, I can say that A for Ellen Segara has boosting factor 5. Shakira, I think this one is Shakira, has boosting factor 2 for this user. If I run this, I will get Ellen Segara quite in a higher position with a higher score than the others. And then the second one is Shakira. Normally they would be way below in the result because they are not very popular in the ecosystem. But for the users who are listening to these ladies, get these content listed on top. Similarly, if I change, for example, another user listening to A1 and A2, listening to too much A1, like I apply 3 and A2 like 1, I should see again Sezen Aksu A1, A2, A2, A3. Oh, it is 1. 1 doesn't make sense, sorry. 1 is 1 multiplied. So Selena Gomez A2 is the second one, and then based on, because they are not interested in by the user, so they just get plain regular search scores based on the length of their content. So 3 minutes ago or 2 minutes ago, my user profile should be updated. You see here, I can see that user 1 is listening to A4, user 2 is listening to A3. This is all done by the process here. Every minute it is processing the raw listen events and then updates these indices. I should be able to see the effect now. If I make the whole search with letter S, but this time including user ranking, excuse me, it is false already, including user profile as user 1, I should see A4, even though she is not the most popular singer in the ecosystem. I get the results listed this way for user 1. And if I perform the same query for user 2, here, user 2, I should see A3 Shakira as the first one. For example, user 2, Ellen Segara is the last one in the list, but for user 1, Ellen Segara is the first one. I still have 2.5 minutes to go, so I can show you, I have time to show you how the index manipulation takes place. I have an event controller, which is simulating the source of events. As I triggered the listen events for user and artist ID, it is going to generate that many events and then send it to Kafka through Kafka template. How this is configured is very simple. I have a Kafka producer config, which takes bootstrap address and very basic configuration for Kafka, nothing specialized here, but I need a Kafka template bean. With this Kafka template bean, I can send messages, Kafka template.send. What I send is basically raw JSON data representing my listen event object. On the consumer part, which is event receiver service, I need Kafka listener. I mark my bean, my service bean with Kafka listener annotation, which is consuming the same topic from Kafka by using the Kafka consumer config. Here, by providing the same bootstrap address and group ID, I can access Kafka and I can start consuming events from Kafka. When I receive a message, all I do is revert it back to listen event because I know that it is JSON string. I can process it through object mapper, read value, and then save it in the listen event. The next thing that should happen is event processing service, which is aggregating the most recent events from Elasticsearch listen event indices and updating the content index, user profile index, etc. As I said, I have only 20 seconds left. If you are interested, if you find some bits and pieces useful for you to take together with you and use in your professional problems, professional work, I'm more than happy to discuss and help you. And I will be very happy if it helps you as well, what I have done and what I have showed you so far. And I'm done with timer.
Awesome. What a great session. I love all the live coding. It's super impactful, and we can see people actually demonstrate everything in action and really show us the power of all the Spring tools that we have in the ecosystem. We have another great case study coming up next. So I hope you stick around. We'll be back in a few minutes.